Okay. Today's notes are only one page, so they don't take that long. We are going to talk about the rational root theorem today and how to find all the zeros of any polynomial. So if a polynomial has a degree n and it's written in descending order, then it is possible to make an organized list of potential rational numbers that could be my zeros. I think so. So the possible rational zeros doesn't mean they're possibilities, but they're better than the infinite list that we're dealing with right now. So these, we're going to narrow down our answer choices. And so we are going to take the factors of the constant term. The factors of the constant term is the last number. So we're going to take the factors of that number and we're going to divide it by the factors of the leading coefficient, which is the q. And they can either be positive or negative, and those are going to be my possible zeros of my polynomial. Now this method, it is not the best, all right? It is kind of an annoying method to do, and so this is what you would have to do if you didn't have a calculator and factoring does not work. If you can factor, that is always the preferred method. All right, so if we can factor something by grouping or X games or any one of those methods there, we always want to try to do that first. But if that does not work, then you would do the rational root theorem. So step one is we're going to find all of our possible zeros. So we're going to make a list of all of the possible zeros. After we do that, we are going to test them. And you just go one by one, and you are going to test them until you find one that works, and you're going to use synthetic division. Now, how do I know when I get a zero that works? What's going to be special?
There's no remainder.
There's no remainder. Yeah, your remainder is going to be 0. All right, so you're going to test them until you finally get one with a remainder of 0. And you're going to continue finding your roots until you have a second degree polynomial. Because once you have a second degree polynomial, then we can factor. Or quadratic formula. Oh, I wrote that down there on step 4. So I guess I don't need it here. All right, so after you get a second degree polynomial, it will either be factorable or you could use the quadratic formula, which both are preferred than to keep doing synthetic division a bunch of times and testing all of my zeros. Okay, so let's take a second and look at the homework.
Okay.
I'll pull it up. And we're going to do the first 4. All right. On the first 4 questions, we are listing the potential rational zeros. We are not finding the zeros. All we have to do is list them. So I want to talk about how you can list your possible zeros, and then we'll get into actually finding them. So on this one, what are the factors of 9?
3 and 3.
3 and 3, but I'm only going to write it one time. What else? 1 and 9. And that's it, because 1 times 9 is 9, 3 times 3 is 9. And that's all the factors of 9. What are the factors of 6?
3, 2, 6, 1.
3, 2, 6, and 1. And that's it, right? So what we're going to do here is we are going to take the factors of 9, which are 3, 1, and 9, and we are going to put those numbers over the factors of 6, which are 3, 2, 6, and 1. So my possible zeros, well, let's start with 3, and let's put 3 over all of these guys. So we've got 3 over 3, 3 over 2, 3 over 6, and 3 over 1.
What about the...
Does that make sense so far?
Yeah.
Okay, so we've taken care of 3. Now, we're going to do 1. We've got 1 over 3, 1 over 2, 1 over 6, 1 over 1. Now we've done 1. And now we have to do 9. 9 over 3, 9 over 2, 9 over 6, 9 over 1. All right, now sometimes stuff repeats, and we don't want to have repeating numbers here. So let's check some of these fractions, especially the fractions that reduce. What does 3 over 3 reduce to? 1 over 1. And do I already have that somewhere else? Yeah, right here. So I'm going to take off this one. We don't need him. He repeats. All right, let's look at another fraction that reduces. 3 over 6, does that reduce?
Yeah, 1
to 1/2. Do I have a 1/2 somewhere else?
Yes.
Yes, I do, so I'm going to take off that one. All right, 3 over 2 doesn't reduce. 3 over 1 doesn't reduce. None of these ones reduce. 9 over 3 reduces. What is
3 over 1?
3 over 1? Do we have that one?
Yes.
Yes, we do, so we're going to take that one off. And then 9 over 6 reduces to what?
3 over 2.
Do we have that one?
Yep.
Yes, so we're going to take that one off. All right, so if you look at your list and you look at the ones that are reducible, is that a word? Maybe, I don't know. The ones that reduce, check to see if they repeat. A lot of times they do, but not always. So don't just cross off all of them, because they don't always repeat, but a lot of times they do. And then the only other thing we're going to do is in front of all of this, we're going to put a plus minus. All right. You could, if you wanted, to write each one with a plus minus, but I think on my key I might have put a plus minus with each individual answer. The order doesn't matter that you write them, and then do what?
Can we reduce them to whole numbers?
Yeah, so if you want to reduce the 3 over 1 to just 3, that's fine. That's probably how I have it on my key, but I'm also okay with 3 over 1. But don't have repeating numbers because that makes things confusing when you go to test them. So technically I have 1, 2, 3, 4, 5, 6, 7, 8. So there are 16 possibilities on this problem. All right, so these are all possible zeros. Not true zeros, but one of these guys is probably a true zero.
And that's the answer.
So all I want to do on 1 through 4 is just list them. I don't want to find them. So right now we're just listing them. Does that make sense? All right, I'm going to give you maybe 3 minutes to attempt the next 3.
Wait, on 3, would it just be 1?
Yes, so on 3, this factor, which it's always nice when it's just 1.
Okay.
Yep.
I would have a 3 factor. Or 3.
What are you talking about?
Do we have to incorporate the negative?
No. Good question. Because the plus minus takes care of the negative sign. Which one are you doing, Chance?
3. 3
Oh, you only look at the first and the last. So you're just finding the factors of 20. And you'll put all of the factors of 20 over 1. So 20 has a lot of factors, though, so make sure you get them all. 1 times 20, 2 times 10.
The last one always going to be the top number.
Mm-hmm. Yep. The last factors will always go on top. So here you would write, because this factor is just 1. So you go 1 over 1, 2 over 1, 4 over 1, 5 over 1, 10 over 1.
Right.
And then plus minus will go in front of it.
I have a question.
Yeah.
Do they put this 8 by 18?
No, if they just put yes or no, but take 5 points off if they don't answer it. So if they just did these two, you can just take 5 points off. As long as they answered it in some way. Does that make sense? I'll get stricter next year with them. Okay, I know you're probably still working, but pause where you're at because I want to make sure I can finish notes. All right, so what you've done is you found all of the possible zeros so far. So let's go back to the notes and let's look at 35. 35 says verify that x plus 3 and x minus 2 are factors of this guy right here, and then find all of the zeros. All right, so I know that if these guys are factors, what is the remainder going to be?
0.
0. So I'm going to synthetically divide. So I'm going to put 3, 2, negative 19, and 6. If I'm going to divide the x minus 2 factor first, what number is going to go on the outside? 2. So we're checking to see if 2 is a 0. And if I get a remainder of 0, it should be. So I'm going to drop 3 down. 2 times 3 is 6. 6 plus 2 is 8. 2 times 8 is 16. Negative 19 plus 16 is negative 3. And 0. So yay, so 2 works. So 2 is a factor. 2 is a 0. And x minus 2 is a factor. Well, I want to test another one. I also want to test x plus 3. You can keep dividing from the same problem. So you don't have to start over in the beginning. Because if you think about like the number 12, right? If I want to check to see if 2 and 3 are factors, if I divide 12 by 2, you get what? 6. And then I can divide 6 by 3, which gets 2. So you don't have to start back over from the beginning, because if it can divide from the original, it should divide from the orange problem as well, if that makes sense. All right, so I'm going to put negative 3 on the outside here because we're going to test the x plus 3 factor. I'm going to drop 3. Negative 3 times 3 is negative 9. Negative 1, 3,
0, 0.
and 0. So yay, that one also works. Okay, so how would I write my remaining polynomial? I started with an x cubed. How many times did I divide?
Twice. So get 2 x's. So 3x minus 1.
Minus 1. Good. So 3x minus 1 is going to be my remaining guy. So I know that 2 and negative 3 are zeros. What would be the other 0 coming from my remaining factor? 1/3. And those are all the zeros of this polynomial. So this polynomial has x plus 3, x minus 2, and 3x minus 1 all as factors. So if you were to multiply all of those guys back out, you would end up with this polynomial right here. All right, so I divided the 2 that were given, and I found the remaining 1 from my leftover.
So which form would we write it in? The x equals or x?
On this one, because it's just asking for the zeros, this is the answer. So just all the x equals. But if it asked for like the factors, then you would want it in the parentheses. Okay, so let's look at the next one. It says find all the rational zeros of this guy right here. So once again, we want to find the zeros. Now, it doesn't give me any starting numbers on this one like the previous problem. So this is where I need to come up with my list of possibilities. So what is the factors of this first guy? 1. What are the factors of 6?
3, 2, 1, 6.
1, 2, 3, and 6. So my possible factors are going to be plus minus 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Does that make sense? So I've got 8 possibilities.
So it has to start on the right and then go over the...
Yes, it's the right one over top of the first one. Yep.
Should we have to try them?
Yep, so we're just going to test them. Which one do we want to start with?
6.
Pick a different one.
2,
Pick a different one.
1,
3.
Nope. 3. Let's start with 3.
Why?
Because I know the answer. So we're going to start with 3, and I'm starting with 3 because I know what the answer is. But if you started with one of these other ones that you said like 1 or 2, you wouldn't get 0 as your remainder, and that would be how you know it doesn't work. All right, so I'm going to put my coefficients in here. 1, the x squared term is missing, so I'm going to put a 0, negative 7, negative 6. All right, so drop the 1 down. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 7 plus 9 is 2. 6 and 0, so yay, that factor works.
So if it doesn't equal, or if the remainder is not 0, can we not continue to divide under it?
Correct. You can't continue. You have to start over. So Peyton asked a good question. If the remainder is not 0, you cannot continue dividing. You have to start over. So the only way you can continue dividing is if you get a remainder of 0. Now on this one, you kind of have two options. You could continue dividing, but you're just guessing now at this point. Or we can write a polynomial because we are now in the second degree. We originally started with x cubed. We divided one out. So I can write this as x squared plus 3x plus 2. And I can factor what two factors multiply to give you 2 but add to give you 3.
1 and 2.
1 and 2. So my zeros are going to be -1, -2, and 3, the one you divided from the beginning. Don't forget about him. Does that kind of make sense? Okay, let's try the last one. All right, so what are the factors of 4?
1, 2, 4.
1, 2, and 4. What are the factors of 3?
1, 3.
1 and 3. All right, so my possible zeros.
1, 1/2, 4, 3, 2, 3/4.
Yep. And then none of those are repeating, and they're all technically plus minus. Now, I would say don't do a fraction. If this was a test question, I would give you a nice number. It'd be something more like 36, right? I wouldn't give you like a fraction. That would be the only one that worked. So odds are 1 or 3 are gonna work. +1, -1, +3, -3. Normally, I would not be mean and make one of the fractions work. So one of those whole numbers will work just because I'm a nice person. Which one do you want to try?
1.
1? Okay. So I'm going to put -4, 15, -8, -3. And I'm going to drop down -4, -4, 11, 11, 3,
-3.
3, and 0.
And now it's
So this one works. And so now I'm going to write my polynomial -4x squared plus 11x plus 3. All right, and so just because we're kind of running out of time, you would factor and you would get 4x plus 1 and x minus 3. So what are the zeros going to be? 3,
3 and
-1/4, and
1.
1. Very good. All right, make sense?
Yes, ma'am.
All right, let's look at, we're almost done. We're almost out of time. Let's look at your homework real fast.
Oh, no. I thought you had more notes.
Nope. All right, let me explain how to do 5 and 6 real fast because they're kind of weird. On 5 and 6, all you're doing is dividing. So you're going to do synthetic division. All right, 4 is on the outside. And the way you're going to write your answer, it says x minus k. So I would write x minus 4. And then in the next parentheses, this is what you get after you divide. Plus, and then this guy here is going to be your remainder. That's the way it's asking you to write it. So x minus k, the q is your quotient. That's what you get after your answer. And the r stands for your remainder. So don't get confused about the way that you're writing that. Those are just synthetic division problems. Okay. So I saw that and I was like, oh, I bet they're going to get stuck. And then I think the rest of it is a lot like what we did today. Bye.